Welcome to The Explainer. Today, we are pulling back the curtain on the secret language that all our smart devices use to talk to each other. It's called MQTT, and, it's the quiet, ingenious reason the entire Internet of Things, well, actually works. So let's get right into it. Seriously, just think about that for a second. Your smartwatch, a temperature sensor in some office building, the GPS in a delivery truck. We're talking about billions and billions of devices. How on earth do they all report in all the time without just completely overwhelming the internet? And maybe even more critically, how do they pull it off when so many of them are running on teeny tiny batteries or stuck with a really shaky, low bandwidth connection? Now that is the real challenge. And it turns out solving this exact puzzle is precisely what MQTT was born to do. So here's our game plan for this explainer. First, we'll break down the specific problems smart devices are up against. Then, we'll properly introduce MQTT, this tiny titan of a protocol. We'll get into how its magic actually works, stack it up against the competition, and finally, we'll see where it's hiding in plain sight all around you. Okay, let's really set the scene here. Picture a tiny little sensor sitting out in the middle of a huge cornfield. Its only job is to measure soil moisture. Now, it has to send that data back to a farmer, but it's running on a small battery that has to last for months, maybe even years, and its internet connection is, let's say, less than ideal. It literally cannot afford to waste a single drop of power or a single bit of data. That's the kind of extreme environment that MQTT was built for. And the solution, this elegant piece of engineering, is a protocol called MQTT. Now, a protocol is really just a fancy word for a set of rules, like a shared language that devices agree on to communicate. And MQTT is a very special language because it was designed from the ground up for those exact kinds of devices, the ones with low power and unreliable networks. So what does that mouthful of an acronym actually stand for? Message Queuing Telemetry Transport. Yeah, I know. But the only two words you really need to remember are lightweight and publish-subscribe. Lightweight is the secret to its incredible efficiency. And publish-subscribe, well, that's the secret to its mind-boggling scale. And you should know, this isn't some new experimental tech. No way. MQTT has been around since 1999, originally developed by IBM. And it's been standardized by the same groups that give us things like Wi-Fi. That means it's a super reliable, mature, and battle-tested protocol that pretty much the whole world has agreed to use. So how does this thing actually work? How is it so ridiculously efficient? Well, it all comes down to its communication model, which is totally different from how, say, your web browser works. When you go to a website, your browser makes a direct, one-to-one call to a server, and the server sends stuff back. MQTT, it's a whole lot smarter than that. Here is the absolute poor idea. Instead of every device trying to talk directly to every other device, which would be total chaos, they all just talk to one central hub. And this hub is called the broker. Just think of it like a central post office or a community bulletin board for all the devices. Okay, now this is where the magic really happens. A device, which we call a publisher, sends a tiny message to the broker. It sends it to a specific topic, which is just like a channel name, say living room/temperature. Now here's the key. The publisher has no idea who's listening. It doesn't even care. Meanwhile, you've got other devices, the subscribers, who've already told the broker, hey, I'm interested in that living room/temperature topic. The broker then instantly forwards that message to all of them. This separation is what makes MQTT so powerful. The publisher and subscriber never have to know each other exist. You can have millions of devices chattering away without any of them being directly connected. It's genius. So if MQTT is so amazing, you might be wondering, why don't we just use it for everything? Well, it really comes down to using the right tool for the right job. And to really get why MQTT is the perfect tool for IoT, it helps to compare it to something you use every single day. First, let's make that lightweight idea really concrete. The header of an MQTT message, that's kind of like the envelope the data is sent in, can be as small as 2 bytes. To put that in perspective, the letter A is 1 byte. So the entire overhead for sending a message is the size of 2 letters. That's it. It's incredibly efficient. And it's a huge reason why MQTT works so well on those slow, shaky networks. So let's put it head-to-head with HTTP, the protocol that runs the entire web. HTTP is designed for one-to-one conversations, like your browser asking a server for a web page. MQTT is built for massive many-to-many messaging. Think back to our little sensor in the cornfield.
Imagine if every time it wanted to send a moisture reading, it had to establish a whole new, heavy HTTP connection. It would be a disaster for its battery life. That's why MQTT's model is just so much better for the world of IoT.
And this table really sums it all up beautifully. You can see the models are totally different. Publish subscribe versus request response. Look at the efficiency. MQTT is very lightweight compared to HTTP's heavier headers. And all of that leads to the real bottom line here, scalability. Because of its design, MQTT can gracefully handle millions of devices. HTTP is amazing for browsing the web. MQTT is for a world of connected machines. All right, so this all might sound a little technical and abstract, but I promise you this protocol is already all around you, working silently in the background. So let's take a look at where you'll actually find it. If you have a smart home, there's a very good chance your lights, your thermostat, your security sensors, they're all using MQTT to talk to each other. And it's not just in our houses. It's in factories, monitoring thousands of machines to predict when they'll need maintenance. It's in modern cars, sending telematics data back to the manufacturer. It's even used to monitor critical infrastructure, like our power grids, to make sure the lights stay on for all of us. So really, the big takeaway is this. MQTT is the invisible, incredibly efficient, and reliable force that quietly makes our modern, connected world possible. But, of course, MQTT isn't a magic bullet for everything. It's important to know that the protocol itself doesn't have security built in. So if you're sending sensitive data, you absolutely have to pair it with another layer like TLS for encryption. That's the same tech that secures websites, the little lock icon in your browser. So it's rock solid, it's just an extra step you have to take. Also, the whole system depends on that central broker. And, as we've said, it's designed for small, snappy messages, not for streaming your favorite movie. But when you put it all together, the conclusion is crystal clear. For its intended purpose, connecting vast networks of small, power-constrained devices, MQTT is without a doubt the go-to protocol. It just hits that perfect balance of efficiency, scale, and reliability. And if you need any more proof, just look at who's using it. The biggest tech companies on the planet, Amazon, Microsoft, Google, they all use MQTT as the backbone for their massive IoT platforms. Why? Because it works. It's reliable, it scales, and it's incredibly efficient. It has truly become the undisputed standard for the Internet of Things. And that really leaves us with one fascinating final thought. As this powerful, efficient protocol continues to weave itself into the fabric of our world, connecting everything from our homes to our farms to our cities, the only real question left is, what are we going to connect next?